I'm Kate Starnes. I'm the developer advocate for KnowThings. So I'm the person who communicates all of the stuff on the community channel and has been sending you a ton of emails. So that's my role, is finding synergies between different groups of developers. Today we're going to cover sorry, I had the wrong window pulled up. Okay, so today we're going to cover what KnowThings is, some ideas for how to use KnowThings, what came out in this most recent release. We're going to show you a demo. We're going to do the near-term roadmap, and then we'll do pricing and licensing. Sue will be kicking off what major features were released right after I'm done. Menka will be doing the demo, and AK will be doing the product roadmap, and Partha will be doing the pricing and licensing. So, what is KnowThings? KnowThings is an IoT device virtualizer. With KnowThings, you can capture, model, and play back real devices, and we can provide you with realistic simulated data that you can use to test at scale for performance. With that, I'll kick it off to Sue, who is our Chief Strategy Officer and Product Manager.
I'd like to welcome you. I know Kate's done a wonderful job, but I am personally so super excited to be here today. I'm excited for the team. We've done a lot of work and spent a lot of time with different users trying to make sure that we were heading in the right direction. We still have a long ways to go, but this is really our initial release of KnowThings, kind of transitioning out of that early adopter phase to actually having a product out there. So I am absolutely super excited to be here. One of the things we'd like to cover is, I know a lot of the people that are on the call today, and hopefully people who will be watching this call later on, they're pretty familiar with what we do and how we do it. But I just wanted to really focus on a few of the top use cases that we have been working towards, and just really helping you understand what we're working towards, and we want you to provide us feedback and making sure, as always, that this is really the top things that you really are working on. So what KnowThings, how we can use, or how you can use KnowThings, it really divides up to about three main things. There's tons of other ones, but we're really focusing on being able to scale up the number of devices for you, extend your data device, and then actually do some performance testing along the way, and really helping you in the full life cycle. So the scale, this is really easy. Early in your IoT development, we've been hearing a lot that a lot of times you have one or two or maybe just a handful of devices, and you're really going to be working on something that might be 5,000, 10,000, or even more devices, but you're really early on, and it's this parallel path between the device and actually having to do the systems work. And so, with KnowThings, sorry, technical difficulties. We have lost my screen share again. I apologize. We're good. Okay, everyone's seeing the screen. Well, I'm having some crazy stuff in the room that we're in right now. I keep losing the screen share. But anyways, for scale, being able to scale up that device, having that one or two devices, and being able to simulate 10 devices, 100 devices, 500 devices, or even more. So that is really one of the main things that people have been telling us that they want to be able to use KnowThings for. The other part is extend your data. So you have those one or two devices out in the field, or you're able to get a recording of 90 minutes, a day's worth of data, but you really want to simulate 2 weeks of data, a month of data. You can extend your device data to what your needs are using the synthetic data and the synthetic transaction. And then if you take both of those in mind of being able to extend your data and then scale up the number of devices, you can really look at your performance testing and being able to really be able to test your systems at scale before you actually go to market. So those are the key use cases that we're working on, and as people that are not as familiar with NoThings start watching this and getting involved with us, we really want to understand that, this is the story we're working towards and making sure that we're heading that way. Like I said, I'm super excited. This is the initial release, and I've told the team here, and I've talked to a few other people locally at some meetups that it seems like we have been doing this for, that this is a mature product kind of from that perspective because we've had the EAP out there for so long. And so this seems like it's just another release, but we are super excited that it is the MVP and it's really the initial release. So, we've been really focused on the developers at this point in time and trying to improve the developer productivity. And we have really, these three areas that we're looking at of being able to improve the developer productivity, test with confidence, and build realistic data scenarios. But all of this is really helping that developer and the team accelerate their IoT solutions development at scale from day one. So let's dive into a little bit more of the feature releases. Or the features in this release and what they mean. You're going to hear a common thing throughout this presentation, and we really want to drive this home that really what NoThings is all about is being able to simulate your system relatively, your devices relatively easy. And so it's a very simple three-step process of being able to capture those devices, capturing the data, being able to model the data, and then being able to play back. And so it's the same three steps that we had in our early adopters program, but it's really the underpinnings of everything that we do within NoThings. The other thing really helping the productivity for the developer, so the simulation of being able to easily capture and model, we also help the developers reduce their risk. We do that by creating larger volumes and, creating those larger volumes with synthetic data. So they aren't playing back the same data over and over again. They get different data points. They get more complex systems being able to, once again, kind of the common theme, augmenting the number of devices and increasing the data volume so you can really test and have a better sense of certainty with your system. And then the third thing that really helps developers is automation. NoThings is an API-first product. For our early adopters, you're quite aware that we have APIs, and the Swagger API is our user interface right now. That's how you can see what our APIs are. You can do quick tests. You can understand that. We also have a very robust command line system that ties into this. So whatever the developer needs from an automation perspective, we make it really easy for them to move forward with that, either with APIs, using the Swagger API on user interface, or actually using command lines, and so they can automate what they're working on very easily. So the testing with confidence. Once again, you're going to hear this common theme of, it's that capture, model, playback. But in the capture part, the communication handshake, other systems that I've worked on from a enterprise an enterprise type solution outside of the IoT world, that handshake and modeling the requests and responses was quite complicated, and if you really didn't know what you were doing, it was really easy to get it wrong. The communication handshake with NoThings is great because it actually goes through and it understands you don't have to worry about that communication handshake. Your device, your software, NoThings learns the request and the response, it automatically detects and actually learns from that. Capture and playback of encrypted data. As these systems, as you're working with these systems, you might actually be needing to capture data that's on a secured network. We are now supporting TLS 1.0 and 1.1. We are kind of jumping into the roadmap section. We're expanding into 1.2 and other things as we hear more from you. And our current Cypher suite is, and this is a lot of words, and I should just put it up here, is the RSA with AES 256 CBC CHA Cypher suite. Once again, we want to hear more from you. I've asked, had a survey out earlier of what your focus is, what your Cypher suites are, what your encryption is, but we can both capture and play back encrypted data so that can really mimic real life. And then the user-controlled playback. So say you got that 90 minutes of data, but you want to be able to test it at a higher speed. So you can adjust the playback to say double the speed, or being able to play it back as quick as in 5 minutes from that 90 minutes, and being able to really focus on that. And you can also add synthetic data as you need it, so it really helps you test with confidence in all of these scenarios. Once again, this is all controlled with API calls. And then building the realistic data scenario. We give you the opportunity to test with lifelike data. It's not playing the exact same data back that you've already captured, and I've lost my stream again. And hold on. I apologize immensely for this. I always love presentations that get a little wonky. So we have the lifelike data. You can identify the data streams within your data, and we'll talk a lot about that data streams in the rest of this presentation. But if you think about it in the easy know things greenhouse that we've used in a lot of demos, and we've used it for common conversations, where you have a temperature sensor, a humidity sensor, and they're controlling a fan. That was one recording off of one device, but we had 3 unique data streams of the temperature, the humidity, and the fan control. And so once again, you're able to identify the data within that recording and being able to use synthetic data on those different types of data. The other thing that we've added just recently in our machine learning is being able to correlate the data of temperature and humidity. We understand those relationships now. We can also generate volumes of realistic data, so you can indicate how much synthetic data you want to generate, and we also have a loop mode, so you can generate synthetic data and have it loop back and just stress test the system. And then test for the unusual, and this has a little star next to it. This is available in preview mode right now. We want to have a better understanding of how you would be using it, how the interfaces are that you would like to have, but this is there to help you test for those error conditions. Those things that don't necessarily show up in your recording, things that you never should see. You really don't want a device to fail like that, but you want to be able to test for if a device failed like that, and if you have particular contract terms that you're working with. So this is something that is, I see it as being something very, very valuable down the road as we expand out and you can really test for those conditions. So really this initial release, it's pretty exciting because we can help you test your IoT solutions from prototype to production. And so with the prototype, we support you in prototyping, providing access for those devices that you don't always have access to. As you move past the prototyping, we help you support your team by scaling up the number of devices, the amount of data you have, and its easy access to it. And then as you prepare to move to production, KnowThings can help you test in that secured environment. And then across all the phases, the API approach of KnowThings is easy to fit into all your automation. So on this, I will hand it over to Minka, and I will have her share her screen so we won't have this wonkiness for a while.
All right.
Thank you.
Thank you, Sue. Can you all see my screen?
Yes.
Awesome. All right. So Sue gave a really nice overview of what we have given you out in the MVP release, and I'm sure you all must be excited to see a little demonstration of how it works. So she did touch up a little bit about the KnowThings Greenhouse application. So what I'm going to do, I'm going to show you a demonstration using this KnowThings Greenhouse app. What this app has, it has a couple of sensors and an actuator, which is a fan, connected to a KnowThings Greenhouse device, which is talking to a KnowThings Gateway server. Gateway server is where we register these sensors, and then we start posting the data to it. And finally, based on the data of the temperature and the humidity, Gateway server decides what the value of the fan should be. And these are all REST calls going back and forth. And on the other side, there's a Greenhouse dashboard app, which actually posts this data and show it on a beautiful web UI. So it shows what the current settings of the temperature, humidity, and fan are, and also the historical graphs of what the data looks like. So like we mentioned earlier, we give you a very easy-to-use solution, which is just spinning off some of the microservices. And let me give you a little glance on what it is like. So there we have a few services that are bundled together in a solution. All you need to do is start one of our scripts, and it spins up all the services at once for you. So I have my services running here. This is my gateway server, and this is my dashboard app running. Now you see all sorts of terminal windows, but how it looks like is what I'll show you. This is my dashboard app, and I have recorded this particular device, the one I showed you earlier. This device, I sent some data to the gateway server, and the dashboard showed it like this. So my temperature started off from here. This is the historical data, and ended up here. That's the final temperature of my device right now, humidity, and fan. So NoThings, you also heard, capture, model, and playback. We have 3 different modes that get you going into what you really want to accomplish. So the first step is to capture. So we have this capture service, which will sort of sniff your data or capture your data off of the network traffic and create a capture resource for you. That capture resource will have a capture ID, which we will use to generate a model. So once we have the captured traffic with us, we will pass it through our modeling algorithm and generate what we call a data model, and we refer to it as adaptive virtual device. Or you'll hear me say AVD a lot. And finally, we will have playback. So let's get started. You saw all my servers running, and we also mentioned that we provide you with a Swagger UI, so it's a very easy way of interacting with our services and getting your job done. In my case, I have done the capture before because it takes a few minutes to do a capture. Just in the interest of time, I have captured the data, and I'll show you. In my capture, I have about 1,217 packets captured. Now, all you're interested in from this is the capture ID. This capture ID that we created, this is what I'm interested in to create an AVD. Now, we conform to REST standards very strictly, but we also know that users don't want to take too many steps to get their work accomplished. So we have provided you with some convenience APIs. For example, it's a one-step thing for you to go from a capture to an AVD by just using this avds.create. So let's try it out. I have it filled out already. This is the capture ID of the capture resource we created earlier. I'm going to try to create an AVD name webinar 1. Let me create it. All right, so let's see. So there we go. We executed that, and voila, we have our AVD created right there. So what you're interested in is it generated an AVD resource, which is the REST resource, and you are interested in the ID of that AVD. You'll be using this to run a playback instance. Now let's go back to my dashboard and see. This came from the original device, temperature 1, humidity 1, and fan 1. And I previously ran some instances to show you some other things. From a practical perspective, I have like 1, 2, and 3 temperature sensors connected, 3 fan actuators, and 3 humidity. What I'm going to do now is I'm going to create another one, because that's what we do. We test at scale. We let you add as many devices as you want. By the way, there's no actual device running right now. What I'm going to do is I'm going to start a new one. And like you saw, I grabbed the AVD ID. And what I'm going to do is, let's not talk about data streams right now. What we will do is just run it. We are not going to give any synthetic data. It's just going to be plain simple, creating a couple more devices. So I just executed that, and it is successful. So what it's going to do, it's going to append my data beyond what you saw earlier. So you will see these graphs moving. There we go. We started over from where we ended. So you can add on the data to the previously captured device. You can create a new device. Now I'm going to create a new device here, but how do I create a new device? Which means I have to give it some new IDs. So that's the concept of data streams that Sue was talking about. What it means is, let's look at what my data looks like for that AVD that I just created. Let's see. So there are a couple of protocols to register my sensors and the actuators with the gateway. And I can pretty distinctly see that the temperature device has an ID of temp1, humidity device has an ID of hum1, and fan has a fan1. Again, super creative. So what we want to do is we want to generate some new IDs. It's like having a new MAC address for a device or a sensor or something. I want to tag these items in my data so that I can replace those IDs at runtime. So the way I will do it is I'm going to tag a few things. Look at this API, tag data string. I'll say that I want to tag temperature 1, humidity 1, and fan 1 as my data streams. As simple as that. And they are tagged. They are tagged with an ID of ID 1, 2, and 3. So what I'm going to do, the concept is that at playback time, I'm going to replace anything with a key of ID 1 with whatever name I want. That's what I'm going to show you now. So everything is tagged. Let's go back to our start here. Now what I want to do is give it some new name, which I'm going to do here. So I want to name it temp2, humidity 2, and fan 2 because that will simulate a new device for me. And notice this time scale that Sue was talking about. I'm running it 10 times faster than I captured it from because, you know, the timing factor. We don't want to wait 10 minutes. So let's execute it. And it's running. And my dashboard already shows my temp2, humidity 2, and fan 2. So you'll see the data progressing. And since we didn't add any synthetic data or anything of this sort, the curve is going to look similar to what we captured earlier, which was this curve. Remember, this came from the second playback that we did. So here, you just created a new device by just that one API call. Now, the next interesting part, and which is a very significant part of our solution, is synthetic data. Now, you captured for let's say 1 hour a day, and you want to simulate 8 hours of the day into your device, but you don't want to keep repeating the same data. You want the algorithm, which is our machine learning algorithm, to add some more realistic looking data within the certain norms. So that's what we refer to as synthetic data. So what I'm going to do, I'm going to call it 2S synthetic, just to make it a little distinct that I'm adding some synthetic count here. I don't know if you noticed earlier, when I showed you the data, I have about 302 messages captured within this AVD. I'm going to add 302 more because it's just visually easier for me to present a point. So let's run 302, add 302 synthetic transactions to an already existing AVD and run an instance. So there we go. And here, my new device is running. It's a new device. This is the ID of the device, temp2S. And it's running 10 times faster, so hopefully the graph will, there you go. So once it's complete, I want to emphasize on what the synthetic aspect is. It's still running. And a way to know if my device is currently running or not is for you to grab this instant ID and go to the API call, give it here, and execute. It's going to give you the status. And it's running in the requester mode, and it stopped. So all my data that was supposed to go has finished. So remember I said I added 302 transactions, and originally there were 302. So sort of just imagine this is kind of like a middle point of the graph. Everything on the left of this line that you're seeing is the original data. Everything on the right is the synthetic data. Our machine learning algorithms, which we have a whole gamut of machine learning algorithms which are doing these kind of calculations, to generate a very real-looking data and add it on to the original data. You will also notice that this data didn't have any kind of trend. It was coming down and going up first, so we generated the data in a certain manner. But let's look at humidity. Humidity had a distinct trend of going up. If we go in the middle of this, these 302 transactions on the right are generated by an algorithm. It detected that there is a trend of the humidity increasing, so it added the data that is more in the increasing fashion. So there's a lot of intelligence built into the synthetic data generation algorithms that we have. Like Sue also mentioned, the correlation. We established the correlation between the independent variable and the dependent variable. Our algorithm was able to determine that temperature is the independent variable, and humidity and fan are dependent upon the independent variable of temperature setting. So it created a regression model and generated the data based off of that. So what I just showed you, this was the playback that I showed you that I ran from here, ADB instances. So let's go back to my PowerPoint slide. What I showed you, we had an original device that we captured off of. We ran it through the modeling algorithm, created an AVJ. And finally, I showed you how there were multiple virtual devices that I created that are running and talking to the gateway server, whether they have synthetic data or not. They can all be talking to the gateway, and from gateway's point of view, it doesn't matter if it's a real device or a virtual device. We can test at scale, we can performance test our gateway, we can test our dashboard app to be looking so much better rather than showing just one device. Here we see a whole lot of devices, and my dashboard looks pretty good. One last thing that I want to touch upon is the loop that Sue mentioned, that you can run your data in a loop mode, and I copied an example earlier so we don't have to run it. Look at that. This is the data I originally captured. When we run in the loop mode, it runs that thing within a loop and several cycles of it. So with the combination of the loop mode and the synthetic data and time scaling, you can really tweak your playback to fulfill your needs of virtualizing the IoT devices. And that concludes my presentation, and with that, I would like to turn it over to Ekad. Thank you.
And I will share.
Or do you want me to see, because we don't have any drops?
I changed my configuration.
Yeah.
So,
All right, cool.
and
You're sharing the notes.
And I changed my configuration poorly. Okay. We'll just hope it stays.
All right.
I apologize.
All right. Well, thank you for the demo, Menka, and I think the entire team, Kate. Thank you, Kate, Menka, Sue. Thank you very much for helping get our first version out the door, getting it and letting our customers know, and both putting together the community that we've had as we have now made our first commercial release. So as founder of KnowThings, the thing I love to do is really talk about the future. What's the next thing that's coming? You know, what we've done gets boring very quickly, at least for me. So I want to share some of what's on our mind for our next near-term goals. One, for longer-term goals, you can always reach out, hit us up on the community, and provide me that feedback, but I kind of want you to know what to expect next. And both for the folks on the phone now, as well as people will be viewing this later, I want feedback on this. This is our best idea based on the early releases that we've done and the feedback we've gotten from our users and customers along the way. But our roadmap, we always want to be responsive to what's really delivering value for you right here, right now. So that being said, there's kind of a couple high-level themes that we're looking at. We are trying to figure out, which is one, how do we really model and handle the oddities of the giant edge networks we're all dealing with, right? So this kind of blows up the problem from traditional software, just in terms of the size and the types of networks that we have to deal with. And so that's kind of looking at some of the things around scalability, as well as Docker deployment and other ways to put our solution where we need it to. The second kind of theme that we're also looking at is how do we continue to support a wider area of use cases and make the simulation as easy to use and as realistic as we possibly can. So let's take a moment to dive a little bit more fully into what we mean. So on the scalability front, we have a full microservices architecture, and we've kind of had that from day one, but we're now going to be making it easy for end users to scale out the playback engines, right? So we can run several thousand devices, in general off of commodity hardware, but you want to simulate millions. It probably helps if we could scale in terms of having a horizontally distributable element. The second part that kind of helps with is we still have needs for geographic testing. So we may want to test from one data center or from, different parts of the globe. So again, being able to distribute and scale out our playback component is going to make it very easy for us to do that. And that kind of ties also very neatly into Docker. It's a very popular platform for containerization. So that is also we've gotten the feedback from a lot of our customers when it comes to containerization. That's what they're using. So we will be working kind of on both of these hand in hand, both making these components easily scalable and then sticking them into a nice, neat container to keep life really easy. I don't think any of us really want to be experts in machines. We want to do software, we want to do devices, we want to do IoT. Figuring out how to deploy this stuff is not the headache we want. That's what we've heard. Now, in terms of also some of the really cool stuff in how do we provide coverage for greater scenarios and make a more realistic simulation for you. So a lot of that comes into what we call model editing. So one of the pieces that we've talked about before, we'll be focusing really on handling some of the date fields in a very intelligent fashion that we call adaptive dates. So this is how we can go ahead and update your timestamps, make sure that the data appears in a very timely fashion. These are kind of those little hidden things that really make the difference between a realistic simulation you can use and one that throws you errors. As Sue alluded to today, with some manual effort and with a little bit of care and feeding, you can add in your min-max scenarios or other things that you have not observed today. But in keeping with our overall themes, I want to make life easy for developers. We're working on features to make it so you're not cracking under the hood and working with us. You can just, we want the Fisher-Price version of this. It should be 1, 2, 3, that easy to create these very fancy type of data simulations. So this is around minimum and maximum, understanding multivariate systems within a set of messages, right? So it's really easy when it's temperature and humidity. We know those are related. Well, if you have a very complex device, it's giving you temperature and humidity from one system. In another one, there's light or other pieces. So we can really now look at the individual data characteristics and the variety of data streams and sort of mix and matching it to that level of intelligence as we pick our independent and dependent variables. And the last piece I just want to talk about a little bit more is as we expand into security in terms of how we handle everything, right? We got to decrypt it before the machine learning can do anything. So with the MVP, we got TLS 10.11 out the door. TLS 1.2 we already know is good as demand. So, thank you guys for answering the surveys that we sent out to get some clarity in it. My other ask is going to be this. As we get below the handshake level, there's also the whole set of cipher suites. And for us in IoT, that can get really ugly, right? You get 4-bit weird cipher suites that we haven't seen before. So please, if you are using the features, or that you have some of these kind of scenarios, let us know. We can throw them in there. We are leaving room in our roadmap to handle additional cipher suites for more security, because that is very important for IoT right now. So I just want to wrap up really quick. At the high end, we're trying to make the solution even more scalable, easier to deploy. We're trying to make the simulations even easier to create. We want it so easy your CEO or your founder can do it. And I don't have to rely on Menka. That's sort of where our short-term kind of future lies. Now, with that being said, this is our first commercial release. So I want to turn it over to Partha, and he can kind of review some of our licensing model. And I'll also add in, I'm sure Partha will cover this, we're looking for feedback on this as well. We engineer the entire business, not just the product. And with that, Partha, please take it away.
Thanks, Eki. Thanks for giving a brief overview on what I'm going to cover. So I'm going to talk today about the licensing model, give you a brief overview on how we are building our licensing. I think both Sue earlier as well as Menka later on covered this concept around data schemes. Menka talked about how do you create a data scheme when you try to model. So essentially this sits at the heart of our licensing model. If we had to think of what a data scheme is, we call this as a collection of data that's associated with a unique message identifier. So by default, each device has a single data scheme. So if you don't go ahead and then define your data scheme to begin with, that's how it starts with. And the way to think about the concept is we want to make sure that we provide you a mechanism where you can distinguish and separate data that's coming out from different data sources. So if you were to think of what an IoT device is, an IoT device either generates the data or gets the data from other sources like a sensor and passes it on to the rest of the systems where you collect the data, process them, analyze, and then make some decisions, right? So what we are trying to do here is to create this mechanism where you can create these data schemes where you can actually send the different distinguished data sources such as sensors so that you can simulate error scenarios or just for scalability. And the best way to do this, even prior to going ahead and licensing, is actually go and download this product and model your data schemes, just similar to how Menka explained in her demo before you go and purchase. So the good thing is both the capture and modeling are free to do in any edition of Nothing. So you don't need to worry about licensing when you actually go and try to determine how many data schemes that you need. And since this is a data schemes is a novel concept, we are totally open to feedback and look to kind of evolve this model in the future as well. So when we released the product, we came up with 2 editions. So the first one is something that's available on preview for a while. It's called Community Edition. This is absolutely a free product where you have the ability to go and download, play with that with a restriction of up to 5 concurrent data schemes that you can play with. That's the one restriction that we have, but in terms of functionality, it's just similar to the other edition, which is the Professional Edition, where the licensing cost is 5 cents per concurrent data stream. It's kind of, we wanted to start in a very flexible and a very economical model, so we just came with this 5 cents. And this has unlimited number of data streams. So it just provides you that ability to scale, as Sue talked about later on, right? Like one of the biggest value prop for our product is to be able to scale, right? Like whether it's scaling the number of devices or scaling the data. So you'd have that ability to scale unlimited number of data streams and test it. And we also provide Slack and email support while you do that. And customers can purchase the product in packs of 100 data streams. So each pack costs, essentially $5 per data stream for any customer. And with EAP discount of 20% for the first calendar year, you'd get it $4 per pack. So it might sound like a cliche, but if you think about that, it's probably comparable or even less than a Starbucks that you might buy. So this we are offering for like now the whole month. So we think it's really a likable pricing to start with. And if you have any feedback, feel free to share with us. So The other flexibility that we are building with this model is you have this ability to kind of increase or decrease the number of packs at any time. So even in the middle of the month, if you were to increase, you would be able to do that, start that immediately. When you decrease, just for the accounting purposes, we don't, change the prorated fees for that month, but it will be effective just from the following month. So I also already mentioned that this discount for EAP customers is available for 1 calendar month. So I would say, if you have been using the product and see the value, I would say just go and take advantage of this EAP discount that's available. All right, so data streams, right? This is, we think since it's a novel concept, it might need some additional thinking. So here are a couple examples that will help to think through this before you go ahead and then do the licensing. So here's an example that's kind of similar to the demo that Menka showed, but it's slightly a simpler version where you have 500 temperature sensors where a customer wants to go and simulate all the 500 sensors that's sending the data to the IoT device. So here the customer is actually modeling the AVD for the IoT device, which actually gets all these sensor data, whether it's external or internal, it just gets the data from there. So here the customer has two options. One is a straightforward option where they can buy 5 license packs so that they can simulate all the 500 data streams, or they can choose to keep this as a black box where the IoT device is considered as one data stream, and they just license for that one data stream and then just go and rock it. Here's another example, right, which is, I would say, much more similar to the demo that Menka showed, where it has this IoT gateway that's involved in the middle, where the IoT gateway acts as an aggregation point for data coming from IoT devices in most cases, but also some sensors directly. In that case, you have this option where the customer wants to first create an AVD for the IoT Gateway 1 for the first month, and then they wanted to go and add on to the other IoT Gateway for the next month. So this is a scenario where they're trying to simulate the two IoT gateways using nothings. So here, interestingly, there are like 4 options. First one is kind of a straightforward and simple, where they think, hey, okay, I'm going to get these 2 IoT gateways simulated. So I want 200 packs for the 20K data streams, and I'll be done with it, right? So that's a easier and faster approach. Then the other approach is, of course, I need only 100 packs at a time for the first month and then the next month, so I can just incrementally add, or after 2 months I wanted to change, I can just go back and roll back to 100 packs as well. So that's that flexibility that I mentioned earlier. And the third option is just consider these 2 IoT gateways as black boxes and then just do 2 data streams for both gateways, or just do one data stream at a time for every month for each of the gateways. So here it kind of begs the question, hey, how do I make the decision? Should I go ahead and then do just one data stream for this one device, consider that as a black box, or should I go and treat individual data sources as data streams and be able to model them so that I get more discrete data or discrete data sources? So here's some of our guidance in terms of thinking, hey, what's the pro and con for going with a single data stream? So of course, going with a single data stream, it's obviously a cheaper option where you don't need to spend as much as buying individual data streams. But in most cases, based on the feedback that we got from our customers, it's not likely to represent the true state of an IoT system. So the complexity of the IoT system, as you all probably know by your experience, would most likely require you to create these individual data streams to get the full value of using nothings. Of course, the single data stream it works for most simpler cases. There are very simple implementations where you're just using it to capture the data and then sending it to the into the cloud or the backend system. That's kind of where you might want to think of using a single data stream. The other con or disadvantage to mention that when you create a data stream, it has an identifier. So that really provides the ability to do this additional security and identity checks, which is not possible if you, create a single data stream to treat the whole device, not as individual data sources. So I think those are like a couple things to think about when you make the decision on how we would want a license. We also have some additional examples in the FAQ, and pricing page also has more details to go and think. And of course, if you have any questions or any other suggestions, please reach out to us. So with that, I'll kind of move to the end of the presentation. This is the statutory warning. Essentially what it means is all the information that we showed here are just for information purposes and doesn't really represent a future commitment. Of course, we want to really evolve the product and then create a product that you guys love and want. So we're absolutely delighted to make this first release. With that, I would kind of turn on to the last section, which is Q&A. We have a couple questions kind of to seed, right? Like if you were to think about, hey, any feedback on product licensing and pricing, you can give that, or you can share how your timing looks like, and those kinds of stuff. So with that, just open up for the questions.
And the line should be open. You can unmute yourselves if you have a question. And also, I'd just also like to add, I know we have a few folks who are planning to watch the recording. Hit us up on community channel, or send us an email. You don't have to ask us live. We're always happy to respond. All right, so nobody likes to sit around forever when there aren't any questions. Let's, all right, I'll give it a 3 count, see if there are any questions. Always look to see somebody unmute. All right, so 3, 2, 1. Email us afterwards if you're feeling shy. We really do love the feedback.
At support@nothings.io.
Yes, at support@nothings.io. Again, for those of you in the Slack channel, feel free to just hit us up there. And, once again, I just want to thank you all for taking the time, both those who are here live and those who will be watching it later. And I really want to thank my team for all the hard work that went into getting this product out the door. I've already acknowledged some of our product team earlier. I also want to give a big thanks to some people who work a little bit more behind the scenes from our engineering team. We have the entire engineering team under Meka, and they put in long hours and a lot of dedication. Daniel is our web and design extraordinaire, so the APIs and all that stuff in the back end. Just want to give a lot of credit out to Daniel for help putting that all together and getting us ready for our commercial launch. And with that, I'll cut you all loose, give you back a few minutes to your life, and again, thank you very much.